Today we start the discussion of Calorimetry, Chapter 11, Class 10, ICSE Physics. Okay, so new topic named Calorimetry. Okay, Calorimetry. So first we discuss what is heat or concept of heat. Okay, let's discuss the concept of heat. Okay, heat. We know that heat is a energy. Okay, it is a energy. And what type of energy heat is? First, we know that structure from molecules. There is a molecule. There is another molecule. There is another molecule. There is another molecule, and these are all molecules. The billion number of molecules to make a substance. Okay, there is huge number of molecules here in a system or a substance. Okay, so these substance and they are molecules, okay, and this gap between two molecules is called intermolecular space. This is called intermolecular space, and you know that. Okay, so if there is a space, so there is a force. Okay, there is a force, and these force, due to that force, they bound to each other. Okay, so that force is called intermolecular force. Okay, intermolecular force. Okay, intermolecular force. Okay, and due to that force, they are bound, and that's why these substances are stable substance. Okay, and so there is an energy, and this energy is called potential energy. This energy is called potential energy. So there is a force, so that's why there is some energy. So that's energy, the molecule are stable. Okay, these are called potential energy. And another concept, this molecule now move in random motion. So that's why there is intermolecular force, there is some attraction or another, they are tightly bound. Okay, so that's why this molecule are not stable here. Actually they are not stable. Okay, so that's why they are move in random motion. Okay, random motion or random movement. Actually, random movement. Uh, and like this, after some striking another molecule, then just displace here this molecule now strike another. So that's a random movement, and that random movement is called another type of motion is called Brownian motion. Brownian motion. So this random motion is called Brownian motion. Okay, and that's why this motion, there is some another type of energy. Okay, after random movement, so there is some motion, means there's some velocity here. Okay, so after striking, the velocity either increase or decrease, so some velocity are present here. So due to that velocity, so another type of energy are present here. So that energy, okay, this is a random motion of the positive energy is called kinetic energy. Kinetic energy. So there we get some two types of energy here. If a substance are made up of molecules, so there is a potential energy, another is a kinetic energy. There are two types of energy. Okay, so there is substance. So if I added two energy, the total energy, that is a potential energy of a substance plus kinetic energy of that substance from given a molecules. Okay, total substance is a kinetic potential energy of the molecule, and kinetic energy of that molecule is called a total energy. This total energy is called internal energy. internal energy. Okay, that internal energy of all molecule of substance is called thermal energy. That internal energy is called thermal energy. Okay, clear? Okay, so that energy of some of the heat, so heat is that a thermal energy. A heat is a form of a energy. That energy is thermal energy, and that energy is belongs to the molecular motion. There is a stabilization, or so called a potential energy. The molecular rest or molecular in motion. So that is means the two type of energy: potential energy and kinetic energy. Okay. So that energy not stay here. So energy is transfer or energy is flow from another body to another body. That the energy is flow. So energy not stay here. So that energy, okay, that the energy flow from hot body to cold body. Okay, the energy flow and that flow is a heat. So heat is a flow. So heat is a form of energy. So definition of heat very important. So definition of heat. So what is the definition? Heat is a form of energy. We know that definition. Heat is a form of energy which flow from hot body to cold body. Which flow from hot body to cold body. Okay, and that is called heat energy or simply heat. So that's called, that is heat energy or called heat. Okay, so that is a heat is, if that is a heat, so that is a measure. Okay, so measurement of quantity of heat, okay, is called calorimetry. So actually calorimetry, what is a calorimetry? Calorimetry is the measurement of heat. So what is calorimetry? Calorimetry is measurement of heat, is called calorimetry. So units of heat, okay, clear. What is calorimetry? Now, calorimetry is not a heat. Calorimetry is a measurement of heat. Heat is an energy. Okay. How to heat is energy related to the energy to heat. Okay. So now the unit of heat, very important concept. Unit of heat. If heat is an energy, if not actually that is heat is an energy, not heat. If heat is energy, that is heat a energy. So SI unit of heat is called joule. If we know that the energy of in SI unit is joule, so heat energy is joule. That is joule SI unit. So another common unit is called calorie. Okay. So calorie is a common unit. CAL. Calorie is another measurement unit of heat. Okay. So what is calorie? Calorie is a definition of calorie. Calories are also a unit of heat. Okay. So 1 calorie is the quantity of heat. So 1 calorie is the quantity of heat. Quantity of heat. Some amount of heat in a heat. Energy. So 1 calorie is a quantity of heat energy required to rise the temperature to rise So temperature of 1 gram of water through 1 degree centigrade. Okay, so heat SI unit of heat is another unit is calorie, SI unit of heat is joule. So 1 calorie definition, 1 calorie is the quantity of heat energy required to rise the temperature of 1 gram of water through 1 degree centigrade. Okay, if I say the 1 calorie of heat quantity of heat energy is released if a fall of temperature of 1 gram of water through 1 degree fall. Okay. So if 1 degree increase or 1 degree decrease, it is either increase, so 1 calorie is needed, either decrease, 1 calorie is lost. So actually the 1 degree increase means suppose the 21 degree centigrade to increase 22 degree centigrade, that is 1 degree increase. Okay, and if fall, that is also 1 degree fall. So any lower limit to any upper limit, but gap between these two limits are 1 degree. Okay, choose any type. Suppose there is suppose x degree centigrade to increase of x plus 1 degree centigrade, any value of x actually. Okay, that is a 1 degree increase, not 0 to 1. This any value of value means I think 10, 12 ppm, any x degree value. Okay. So what is the relation between calorie and joules? Very important. So 1 calorie, you know that actually 1 calorie that is equal to 4.186 joule, that is similar to 4.2 joule. That is relation between calorie and joules. Okay, clear. Next, if I said that is 1 kilocalorie, suppose very easy. If 1 kilocalorie, KCL, kilo means 1000, so 4.2 times 1000 joule, so that is 4200 joule, and also called 4.2 kilojoule. Okay, that is a kilocalorie. So what is definition of kilocalorie? Very important in board question. Definition of calorie, definition of kilocalorie. So if I write a definition of kilocalorie, so that kilo represent the mass of the substance actually. Okay, that is the represent mass of the substance. So here previous 1 calorie means mass of the substance is 1 gram. Is 1 kilocalorie means so mass of the substance is 1000 gram, means 1 kilo. So 1 KCl is the same quantity of heat energy required to rise the temperature of 1000 gram or 1 kg of water from suppose 10 degree centigrade to 11 degree centigrade. So 1 degree is increase. Okay. Okay. So 1 degree centigrade. Either suppose these are the x degree centigrade to x plus 1 degree centigrade. Both are the same. Okay. That is not confusion here. Okay. So if we discuss, I think there is a clear the concept here. What is the heat and what is the calorimetry? So now we discuss the concept of temperature. Discuss the another concept of temperature. So what is temperature? Temperature is a parameter. Temperature is a parameter. Temperature is a parameter to define the direction of flow of heat. To define the direction of flow of heat. Okay, is a parameter. Okay, so temperature actually tells us the thermal state of the body. If that is a hot, or also actually say thermal state of body. So actually body is hot or actually body is cold. If someone says that a temperature of that body is suppose 1 degree centigrade. So that means that's a cold body. If someone tells that body is suppose 90 degree centigrade or 110 degree centigrade, so that means the body is a hot body. So that is a cold body. So that is also parameter, also tells the thermostat of the body or degree of hotness and coldness. And another is called degree of hotness and coldness. Okay, degree of hotness and coldness, and direction of heat flow from two bodies, difference between temperature, which body, hot body to cold body. Actually heat flow from hot body to that cold body. If suppose take an example, there is a two body, that is a body 1, there is another body 2. The heat of the body 1 is a Q1, heat of the body 2 is Q2, temperature is T1, here temperature is T2. If say we will say that temperature 2 is greater than, say, let's say 2 is greater than temperature 1. So actually temperature 2 is a hot body, and respect to B2 body 2 body B1 is cold. So if we connect between these two bodies by any path that path a good conductor of heat actually. Okay, so we see that, so hot body to lost some heat and cold body gain some heat. Okay, so hot body lost some heat and cold body gain some heat. Okay, so that is a heat difference. Okay, so after they are when they are in same temperature actually. Okay, or they are actually same temperature. So actually that hot body loses some heat and cold body gains some heat. So actually Q1 is less than Q2 and T1 less than T2. Okay, so cold body gains some heat. Okay, so hot body lost some heat. So that is a flow of heat. So that temperature T1 and T2, that parameter actually defines the direction of heat flow. The temperature is the direction of, this temperature is direction of the heat flow. Which direction actually? Okay. So the amount of heat energy contained in the body depends on another factor here, some mass, temperature, material of the body. So later we discuss here. Okay, so now we discuss the unit of temperature. Okay, so unit of temperature. So actually you know that unit of temperature very easy. We know that the SI unit is Kelvin. Okay, so suppose and called K. The another unit is called not SI. It's called Celsius unit. Celsius. And this Celsius is called degree centigrade. Okay, so there is some relation between Kelvin and Celsius. Suppose there is an x degree Celsius, there is a formula that is equal to x plus 273 added at Kelvin. That is a relation between centigrade and Kelvin, sensor Kelvin. Okay, so suppose we tell that 0 degree centigrade means 273 Kelvin. If that is at 100 degree centigrade, that is also equal to 373 Kelvin. Okay, and if someone say that is 0 Kelvin means minus 273 degree centigrade, and the 0 Kelvin scale is called another name. It's called absolute zero. It's called absolute zero. Okay, so that is a actually these are called absolute zero because there is a absolute zero means actually that is a impossible. So at that temperature there is a actually any object are not found in that temperature. Okay, the mass becomes zero actually. No significance of that body at that temperature. Okay, so actually the body gets a zero. That's why it's called absolute zero. The mass is zero actually. Okay, that's why these are called absolute zero. Clear? Okay, that is all zero. That is impossible. But actually in Earth, I think there is a minus 70 degree, 60 to minus 60 to minus 70 is actually measured in that real life. Okay. Yeah. Now the next concept discuss factor of affecting the quantity of heat absorbed to increase the temperature of the body. Okay. Actually, we discussed this part. Okay. Factor affecting. That's very important also. The factor affecting the quantity of heat of heat absorbed to increase absorbed to increase the temperature of the body. The temperature the temperature of the body. Okay. Factor affecting the quantity of heat absorbed increase the temperature of the body. Okay. So there is a factor here. Okay. So that is here this diagram actually there is some factor to depending. So heat energy is absorbed. Okay. How amount of heat energy is absorbed. So first factor number one is the mass of the body. Mass of the body, very important. Okay. So actually mass of the body is very important. Okay. So here previously discussed the definition of 1 calorie. So definition of 1 calorie and 1 kilocalorie. Okay. So if you clearly noted that definition, see 1 calorie heat is required to raise mass of the body is 1 gram if we raise the temperature 1 degree centigrade. That is 1 gram need 1 degree centigrade increase or decrease. The need is 1 calorie heat. If 1000 gram same amount of temperature increase or decrease, we needed of heat is 1 kilocalorie either absorb or release. Okay. So more mass is more heat is needed. Is less mass is less heat is needed. So that's why it tells that the heat and mass, absorbing heat and mass or release the heat of mass, heat and mass of the body, they are directly proportional. If we represent a heat, symbol is Q. Q actually this Q, Q represent heat actually. Okay, that's Q is represent heat. So Q is directly proportional to mass of the substance. If more mass, so more heat is needed. Less mass is less heat is needed. Okay. Now that is another factor. Number 2. So another factor is the temperature. Important. Temperature difference. Temperature difference is very important. Okay, because I see that is 1 gram water. If check that is a 1 gram water to increase the temperature of 1 degree centigrade, so 1 calorie heat is needed. If same 1 gram water, we need to increase the temperature of suppose 0 degree to 100 degree centigrade, 0 to 100. Okay, so there is 0 to 1 and here 0 to 100 degree centigrade increase. So not we don't need that small amount of heat. We need a huge number of heat. There's suppose that is the two same bowl. We need to 1 degree centigrade. So 1 calorie heat is enough. If same amount of 1 gram of water, 1 gram, but we increase the 90 degree centigrade, 1 calorie is not sufficient. We need a more amount of heat to raise the temperature from 0 degree to 90 degree. So that's why it is the temperature difference and the mass of temperature difference and heat actually heat and temperature difference actually discuss here. Heat and temperature difference, they are also the directly proportional. So that Q, that heat and temperature difference is also the temperature difference, the delta T, that is directly proportional. Is a more temperature difference, it means a more amount of heat is needed if same amount of mass. Clear? I repeat that. If same amount of mass, if temperature difference is more, so more heat is needed to raise that temperature, upper limit of the temperature. Okay. Okay. So temperature difference, and third point is important. Yeah, substance. Okay, and call some material property. Different substance have the different amount of heat. So actually, different substance need different amount of heat. Okay, so if I combine these two, 1, 2 actually, combine that 1 and 2, that is 1 and 2. Suppose combined heat is proportional to m delta T, heat is also proportional to m and heat is also proportional to delta T, temperature difference. So if we remove that proportionality sign, we get some constant, and this constant is called C. This constant is called C. Okay, and this is a proportionality constant. Proportionality constant. Okay, the proportionality constant, and name that proportionality constant a specific name. Okay, actually it's called specific heat capacity. It's called specific heat capacity. Okay, this is called specific heat capacity of a given substance or of a substance. Okay, so that is the important formula, that Q equal to m C, or some C shifting here, that is delta T. Okay, there is a very important formula. So today end the class here. Thank you.